In this set of homework problems, we are optimizing multivariable functions. And because they are all application problems, we need to read through the problem and determine what the objective function is and if there are any constraints. If there are constraints, we need to use the method of Lagrange multipliers. If there are not constraints, then we simply find our partial derivatives, set them equal to 0, and solve for the variables. So in this problem with Skagway Coffee Company, we're given a cost function, and we are asked to minimize costs. So we know what our objective function is. It is the cost function. And you will notice that there are no constraints. So this is not a Lagrange multiplier problem. Simply find our partial derivatives, set them equal to 0, and solve for x or y. So let's find the first partial derivative with respect to x. And so that's going to be 2x plus 6y minus 200 equals 0. The partial derivative with respect to y is 6x minus 12y is equal to 0. All right, so those are our partial derivatives. Now, we want to create a system of equations. We have two equations in two variables. And solve this system of equations by any method that you prefer. You can use an algebraic method. You could use matrices if you'd like. I'm simply going to use the algebraic method because this is going to be easy enough. We just multiply the first equation by 2. We will have 4x plus 12y equals 400. We don't need to do anything to the second equation. And we end up with 10x equals 400, or x is equal to 40. So x will represent the quantity in pounds of its premium blend. So 40 pounds of the premium blend. Now the answer says, leave it to the nearest pound. So this already is to the nearest pound. We don't need to do any rounding. That's nice. So the next thing we need to do is to find y. I'm going to go to this equation because it looks like the simplest one to work with. 6x minus 12y. So we have 6x minus 12y equals 0. Substituting in 40 for x minus 12y equals 0. So we have 240 equals 12y, so y is equal to 20. So 20 pounds of the other blend. And so the final thing we need to do is to find the total minimum cost. And so we're going to evaluate the function at f of xy, which is going to be at 40, 20. And I'm going to let you do all the arithmetic there. I would use Desmos or graph calculator. I like to use Desmos. Just put the equation into Desmos and evaluate it at this point. And I believe that that should come out to be 6,000. All right, hope you enjoyed this video.